Hello everyone, this is Arjun Subramanian Ganesan, and I'm going to talk about a project called Design and Implementation of a Reliable Wireless Communication System using Channelization Protocols. This is a project that I'm submitting towards the final coursework of my Wireless Communication course EEL 6509 in spring 2016. Now I'm going to talk about the motivation behind this project. Wireless communication is a widely sought after field in the current day and age. With the rise of technology and the potentially unlimited possibilities of connecting devices, the field of wireless communication is more important than ever. The advent of Internet of Things has become a boon for many people across the world, making life easier by connecting a plethora of devices to the Internet and to each other. These devices are often connected through small networks. This calls for the development of a new reliable communication architecture for reliable transfer of files across small networks. Introduction. Small office spaces and medical facilities often have the need to transmit and receive small files such as documents or X-ray images among the many users in a small LAN. This project proposes to design and implement a low-cost solution for the aforementioned issue. Since the system is designed for a multi-user network sharing a single channel, CDMA spectrum technique is used to minimize the data signals across many users in the spectrum to minimize peak power. After the data signals from the senders are spread across the spectrum, the resulting file is then transmitted to the receiver via a socket connection. Now I'll be talking about the CDMA spectrum technique used in this project. Many media access control protocols were studied and analyzed for implementing the proposed reliable wireless communication infrastructure such as Aloha, Slotted Aloha, TDMA, CSMA, CSMA-CA, and CSMA-CD. Post-analysis, it was found that CDMA offered a performance that was superior than other techniques in the same category. Hence, CDMA was decided to be the media access protocol for this architecture. In a system that uses CDMA, each sender is assigned a unique ID that serves as both a security and encoding feature. The data bits from each sender are encoded using these unique IDs, and the resultant data is the data that needs to be transmitted. Now I'm going to talk about the working of CDMA spreading. Each station in a multi-user network is given a unique ID for encoding the data signal of that user. The data signal from that user is encoded with a corresponding unique ID to create the resulting data that will be transmitted across the socket. In the diagram in the right side of the slide, we can see the data signal represented by the first waveform and the code signal, which is the unique ID given to that particular user in the network. The resultant signal is the coded signal, which is obtained by performing an XOR operation of the data signal and the code. This resultant signal will be the signal that is transmitted across the socket to the receiver, which resides in the same LAN. Now I'll be talking about the socket-based data transmission and reception. In order to provide a reliable mechanism for small networks to transmit and receive files reliably, a socket-based communication mechanism is used. Sockets usually come in pairs, a client and a server. They reside between the application and transport layer of the node and can be configured as both sender and receiver. Sockets are bound to applications whenever they request to initiate a data transfer within the same network or outside the firewall. In the case a same network is used, private IPs are used for the transfer. In the case of a different networks, to overcome the firewall, public IPs of the server and client are used for the transfer. In this project, we are using private IPs because we are sending files across the same LAN. Now I'll be talking about the working of socket-based transfer from the server's perspective. This project makes use of a connection-oriented implementation of a socket. Each socket is paired with a port number that the sender and receiver mutually agree upon, and the data transfer takes place through this port. In this connection, the server opens up a socket by invoking the socket method. The invocation to bind method is followed by this, where the application is provided with a unique descriptor for the socket. Then the server starts listening in on the channel for any incoming data transfer requests. Now I'll be talking about the working of socket-based transfer from the client's perspective. The client wakes up just as the server does. It invokes the socket method to create an interface between the transport layer and the application that is requesting the socket. The bind method is then called to create a binding between the application and the socket. Post this, the client invokes the connect method when it has data to send to the server. If, when the client sends the connection request, the server is in listen state, the connection is accepted by the server and data transmission commences. Once the server accepts the connection request, the various methods provided by the socket API, such as read, send, receive, can be used to read and write data to a shared buffer. The sender writes data to this buffer and the receiver reads the data from the shared buffer. Once the data transfer is complete, the connection is either terminated or stays open for future transfers. Now I'm going to talk about the advantages of using a socket-based data transfer. The socket-based data transfer technique followed in this project provides a lot of advantages over conventional methods of data transfer. Number one, it is an interface provided by the operating system and does not need to be set up for each use and does not need to be set up for every time. It is bound to an application and not to a host. That means each application on a host computer can have its own dedicated socket for transmission and reception. It can be implemented both as a connection-oriented and a connectionless network. Now I'm going to talk about the experimental setup for the proposed wireless communication infrastructure. The block diagram of the experimental setup is shown here. Application A, which is the sender, wishes to transmit data to application Y in the same computer or another computer within the same network or outside its own network, in which case it needs to bypass the firewall. The file that application A wishes to transmit is spread across the spectrum for minimizing peak power and encoded the information in case multiple users require access to the channel. This spreaded data is then transmitted to the receiver through the socket of the sender. On the receiver side, the socket that corresponds to application Y receives the encoded data, despreads it, and passes on the original file to application Y, thus completing the whole flow. Now I'm going to talk about the working of the proposed communication architecture from the sender's perspective. The experimental setup consists of two computers, one sender and one receiver. One of the computers are configured as a sender and the other one is configured as a receiver. Both of them have a socket program which is programmed using Java, up and running, and the port numbers are fixed accordingly. Now an image file or any other data file is pushed for CDMA spreading. A program coded using MATLAB converts the input file into a spreaded form and places it in the buffer of the socket, indicating that the sender is ready to transmit. Sockets basically have a shared buffer of sorts where the sender writes data onto the buffer and the receiver reads the data from the same buffer. The same process is followed here in this project as the socket-based communication is used. In this project, the sender and receiver are configured to transfer via port 9999. Now I'll be explaining the pseudocode for this project. If application A is ready to transmit, the file that needs to be transmitted is fetched from the disk and is sent for CDMA spreading. The socket method is instantiated to create a connection. Post this, the receiver waits for the server to go to the listen state. Once the listen state in the server is detected by the receiver, it sends the connect method, which is a request to initiate connection between the server and the client. Post this, the sender starts sending a file via the socket created for application A. After the receiver receives the entire file, it sends an acknowledge message, and after this, the client closes the port, and so does the server. This is a connection-oriented implementation of a socket-based protocol. Working of the proposed wireless communication architecture from the receiver's perspective. Initially, according to the flow described in the previous slides, the receiver initiates the communication process by invoking the socket and listen method. Once the receiver sees the listen method, it takes the data and places it on the shared buffer for the receiver to read from. The receiver then invokes the read method to read data from the shared buffer. It then places the data that is received into the memory of the receiver and pushes it for desplitting. The image file received by the receiver through the socket is sent for the CDMA part and desplitted. In this case, there is only one sender. The data from the sender is spread across the entire channel for power minimization and reducing peak power. After desplitting the image, or any file for that matter, they are stored on the memory of the receiver. In this case, they are stored on the memory which corresponds to application Y and is allotted to the same application by the operating system.